Okay, welcome everyone. This is Jim Spohr and Professor Louis Freund of the Mighty Me platform fame. This is our monthly second Wednesday of the month T-shaped development speaker series. And I'll put some links in the chat later. But today we're very fortunate to have two presenters, so we want to get right to it so we have plenty of time to hear their presentations as well as to ask questions. And I'm going to ask them both to introduce themselves and then take us through their presentation. And we have distributed these papers to everybody in the speaker series, so hopefully people come in prepared with questions and already a little bit familiar with the work. So let's start with Juha Saukkonen from Finland. And Juha, could you introduce yourself and take us through your presentation? Then we'll go over to Patrik.
Yes, definitely. Thank you, Jim, for the introduction. So hello, everybody. If you're in Europe, good evening. If you're in America, I think it's good morning. We are preparing for an eclipse here in Europe. We will have it partial, whereas Spain and Iceland will have a total eclipse later today. So it's an exciting day for many people in here. So my name is Juha Saukkonen. I work here in the University of JAMK, University of Applied Sciences in central Finland. And in my school where I'm working at is School of Business, and more specifically, I'm teaching and doing my research in the in the development and educational program of international business. And also futures foresight is very close to my heart. I have been publishing on topics related to futures foresight. And the paper I'm talking about today is a paper originally I presented in the engineering conference in Barcelona, Spain, some 4 years ago. And I had the same year, I also had one T-shaped capability mapping paper in another conference, but my material is mostly about that one conference. So the question is that could we develop the T-shaped capability model further so that it would better fit into the way the people in the companies, people in universities and so on think, and it would reflect the workplace reality, which to me is the most, the thing closest to my heart since I'm educating the future employees for the companies and organizations. Let's see, okay, sorry, I'll go back to the sharing. Something happened with my sharing.
Could you try just stop sharing and reshare again? Or there you go. Now we see the...
There we go. So some words about the key concepts is, first of all, that the skills can either be seen bounded by the context where the task or the situation appear, or being independent of the context. This is maybe one of the, on this page, the thing I want for us to focus on, as I have later on developed the model based on the context specificity versus generic type of capabilities. And the skills, yes.
Could you go into full presentation mode? And I don't see your slides advancing, so I don't know if others... There we go. Now
Okay.
You go into full
Okay,
screen.
sorry for that.
And if you can go into full screen, it'd be even better, but we can see it okay.
Okay, I see it as full screen, so I don't know what is happening right now, but
okay. Oh, don't worry about it.
I think you want to be in presentation mode.
I stop sharing still once, and then I share. I go
It was
there.
sharing okay, but it wasn't being...
And then presentation mode. Better now?
That's okay. Just continue. Just continue.
Okay, I continue. Okay, so what is happening at the moment across the spectrum of competencies for the workers for tomorrow, that they will need to plan for a much longer lifespan with many career and life transitions. So the skill sets of the future workers will be richer, and they will be more versatile, and they will be more changing than they have been so far when we look at the workplace realities, how they manifest to the people who are entering the workforce and who are educating for their future careers. So the original task I set to myself is that could we provide a new improved model on capability profiles, and how could we contribute to the knowledge management field of science in what comes to capability mapping and planning for capabilities. And this is a bit of the history that you most likely know of. How have we got this far? Is that we started with the I-shaped people. We were training people, going deeper and deeper and developing narrow capabilities, narrow expertise. And the idea was that when an organization has a lot of I-shaped people whose capabilities or expertise complement each other, then the whole spectrum of expertise needed will be covered. But then the T-shaped model, of course, as we know, developed because those I-shaped people or people with I-shaped capabilities were not able to build bridges between their capabilities. And then came the ideas of V-shaped capabilities, so two deep skills combined with some combinatory capabilities. And then, for example...
Again, I think your slides are not advancing as you're speaking. We're still sitting on number 2, key concepts. You're way ahead of the slides.
And now what I see is my slide number 3.
Yeah, we were not seeing the same thing.
So...
Sorry to interrupt.
No, it's my bad. My bad. What is the slide you are seeing now?
Number 3.
Now it's number 3. Okay, right. I'll try to use the page down.
That's better.
Okay. And then came the extended T-shaped model by the American and Sporer for already 11 years ago, with many disciplines, many systems, at least one discipline, one system, one culture mastered. So multiple deep skills and multiple wide skills. And the dilemma, my comment was then, and still is, that the dilemma is that the future expert is that they are either very generic, those skills that we are describing in these models, or they are overloaded with layers and capability areas. That was the impression I got then. I will show you in the end of my presentation a bit how my thinking has changed a bit. So I made a conceptual paper. Can you see my slide number 4 now?
Yes.
So it was based on inductive reasoning. So I did some analytical assessment of prior art models. I had observations of knowledge management practices in organizations, and I had discussion with knowledge management stakeholders in industries and education. And then I came up with the idea of what I call T2 or T to the power of 2 model. And what I say here is that instead of having only one layer of those horizontal capabilities, those combinatory wide capabilities, we could separate them to generic capabilities that are independent of the context where you are practicing those skills. Things like global view, quality focus, technical literacy, financial literacy, they are independent on the context pretty much in today's world. But then we have industry and company specific or organization specific contextual capabilities where you need those wide area of skills, and still you need the deep special expertise that is the main reason you are hired to an organization, if we take it in a very simple terms. And how to apply, I then created after these discussions with industry stakeholders, some instantiations, potential instantiations of the model. So how would these models look in reality? I created one for a software engineer in an industrial company in the paper, and then I had another one for the digital marketing lead in an industrial company. So there are some same capabilities, but for example, of course, the area where the deep knowledge is needed changes from one job to another. And then to test the model, I took the 24 capabilities for the future that the World Economic Forum published in their report. And I asked people to say that, okay, if you think about those 24 capabilities, which of them belong to this deep layer or vertical layer where you need a deep knowledge when you work as a digital marketing manager or digital marketing lead today, and which are the capabilities that belong to those wide combinatory, either generic or context-bound capabilities. And then I started also applying thinking that the expert level is the same thing as the depth of the T-shaped model. Advanced level applies to those context-specific capabilities, and basic level applies to those generic capabilities. So I was combining here the thinking of the traditional learning pyramid or the skill pyramid to the T-shaped model. Oh, sorry. And this is an example of the mapping I got from one expert. So the job role was digital marketing lead, and the respondent to my query was a marketing educator in a university. And you can see that the skill set is huge. It's very versatile. It's very rich. And for example, in the expert level knowledge or in the deep level knowledge, there were altogether 6 different skill sets from the World Economic Forum that this person was listing as the skills where you need a deep expertise. Is that realistic? I don't know, but at least it tells about the very, I would say, problematic situation we are facing as educators, that we don't have any more time, we don't have any more resources to give education to the future workers. Yet the demands and expectations for people's capabilities are growing all the time. Yes, the technology, for example, AI, can speed up learning to a certain extent, but it can also, when used badly, it can harm learning. So how can we impact the accumulation of knowledge in our field of science? So to address the question that Jim asked already in the introduction is that we should try to publish as much about the T-shaped model, whether it's my model or somebody else's model. And we should really get also the educators on board. And for example, the educators are really talking about learning pyramid. So the basic skills, advanced skills, expert skills. And it's kind of an inverted model compared to what I proposed in here. So there has been good activity. I think 10 years ago, there was a lot more, that's my observation, there was more activity on T-shaped capabilities in educational institutions than there are today. So partly because of AI taking role of everything we discuss about learning nowadays and skills. So we who are into it, we have to keep the flag high and keep talking and keep publishing about it. That's what I had in mind for today.
Great. Thank you. Thank you, Juha. Questions for Juha? I've got one more, but let me give space to other people. Yeah, my question, if no one's jumping in, is there's quite a bit of work that you have to do for each type of job role, Juha, in your model.
Yeah.
And that extra work is great. And
Yeah.
it reminds me of something that Lou is working on called persona. And he's developing a whole set of persona on the Mighty Me platform for different types of people. And I'm just thinking that might be a fruitful area, Juha, for you and Lou to get together and collaborate on in the future. And so it's more of a comment than a question.
Yeah, I was actually intrigued by the positioning of the T-stem, the idea that the T-stem relates to something in the T-top.
Yeah.
That helps me a lot, frankly, in thinking about how the T-stem and T-top are aligned. So appreciate that model.
Yeah. To Jim's comment, I have published one I also teach and research HRM, human resource management. So I do have published one paper about personas and persona concept. And what is there kind of typically when we talk about persona, we add psychographics there. What type of a person, what type of a thinking would be needed to master the skills of the future. So thanks for the comment and the hint. That might be a fruitful area.
Yeah, great.
Because capabilities and persona, the psychographic. So you need a certain type of mindset. You need a certain type of gifts, talent to be able to learn the skills and capabilities.
Perfect.
So I will take that to my rucksack and start thinking how to apply that.
Excellent, excellent, Juha. Okay, going once, going twice. Any other questions for Juha before we shift to Patrik? Okay, and Juha, if you could send me, if you're willing to share your presentation, I'll get that uploaded to the ISSIP community as well.
I will send it to you. I will double check. There were a few things that were not formatted as I wanted to, but I will send it to you. Yep.
Thanks, Juha. Patrik, over to you. Please introduce yourself, and I'll just say that we've already heard from Leonard and some of the others in the research team that Patrik is part of. So they're very active, and Patrik has some interesting stuff to share. So Patrik, please introduce yourself and take us through your paper.
Hi.
Presentation.
First, can you see the presentation fully, or do you see
Yeah.
PowerPoint?
No, we see it fully. It's good.
And the slides changes, right?
And the slides are changing.
Okay, everything works. Perfect. Hi, I'm Patrik Prochazka. I'm from Czech Republic, from Masaryk University. As Jim stated, a few colleagues of mine already give a talk in the series. And let me introduce you our concept. We found it's called Multi-Centroid Traversal for Explainable T-shaped curriculum. It's kind of hard, but let's dive in and you will see what's about. Thank you, Juha, for introduction of the T-shape. It will save me some time. So we just get right to the problem statement. And the problem statement is, the problem is that the universities and its study programs, at least in Czech Republic, tends to fall behind even faster, and the gap with AI is getting bigger and bigger. And the adaptability of the academia is really slow. So many people question if they even should go for degrees, and we think the academia should be someone who is first with the innovations and not the last. So the curriculums could work. Let me give you an example. When I am a freshman at the university and I came on the Faculty of Informatics, and I will tell, or I will set in the system that when I finish my studies, I want to work as an enterprise Java developer, and I will get tailor-made study curriculum for that. So yeah, you get the right competencies for that. You will learn Java, maybe a few other programming languages, but then you will learn advanced concepts in Java purely. You will learn about Spring Boot. You will learn more about databases than someone else who wants to be data scientist, right? He will learn more about Python and how to prepare data pipelines, etc. So the difference is it should be tailor-made for the student's needs and to shape his T-shaped skills during the studies already. So we had a proof of concept done. It was done by one of the master students in our laboratory. And it was a good idea. Jim was part of it. And we found that there are some limitations but it's just a proof of concept, right? It proved the concept, it worked well. But the limitations are there was a semantic shallowness that was by algorithms selected, and it was working mainly for, I'm sorry, it was built for a Faculty of Informatics, not for the whole university. And the optimizations were pure black box. It was a mathematic model, mixed integer linear programming, and it was doing the recommendations, but not in a way how we propose in the multi-centroid concept. So we have a data. We have a data about courses from university, but it's just a syllabi data, right? And syllabi also tends to fall behind what's actually learned in the course. And to upgrade the data that are coming into the system, it's just in that LLM. It's trendy, right? But you can use the large language models to analyze the lecture slides. You can take transcriptions of the lecture recordings and let the LLM point out the core concepts, because there can be a lot of useful stuff in the recordings, right, that are not in the syllabi data. It's actually it's to use the content of the lectures to enhance the context of the courses, right? And then when you enrich this syllabi data, build a knowledge graph about it. Not just some similarity and thing, but really connect the nodes in the graph. Let's talk shortly about dataset. We tried to analyze 2 last semester from four faculties out of 10 total in our university. For these 4 faculties, it was more than 1,800 courses. That's quite an amount of data to analyze, and we found there are almost 1,000 prerequisites identified in the links between the courses. But these prerequisites can be cumbersome or not. It's artificial but someone says that before you take advanced programming, you should have the basic programming class, right? But someone coming from high school, technical high school, can already have the basics of programming, and then he needs to take 1 course more to be able to move his skills forward. So that's about the prerequisites. Sometimes it's not really helping students. Then also part of the dataset should be a job market data, the competencies that are required for the job for the positions, what the job market wants right now, what's trending, what are the companies hiring, and it's the analysis of data from the job market, right? And then also we need to map these competencies to the course data to find what course give you which competency. And of course, it's not one by one. I will get to it. So when we are building the knowledge graph, just to be sure to introduce the topology, the nodes represents courses and the competencies. Edges are the hard constraints. These are the prerequisites from the system, and also semantic connections that we are bringing in. The edges between courses and competencies have weights that give the completeness of the competency or reaching the competency. And this value, it's important to mention it should be context dependent, because some competency is more important than other for different profiles, right? Someone really needs the programming, so the weight should be higher. But if you are if you want to be a product manager, the programming has a lot lower weight, because it's nice to have a technical understanding, but it's not your priority to become the best programmer, right? And we took the syllabi data. We created a graph based on Faculty of Informatics, and we found out the data are in this shape. You can see there is a group of subjects. This is just illustration of the graph, because there were many nodes. This is simplified, but the shape was the same. There was like 60 courses that were really bound together by the prerequisites. And these were the core courses that almost everyone is going through their studies at Faculty of Informatics, different study plans, etc. But the rest of the courses is not somehow connected to anything. It just lying there in the knowledge graph, no connections. So yeah, that where the LLM what brings in that it can connect the courses together on a semantic level, right? So let me introduce you the ideal graph. We tend to have as a source for our algorithm and the course recommender, and it's the orange, the yellow ovals are the competencies. The circles are courses. Black, I don't know how the colors are visible, but the black lines are the prerequisites. Orange lines are competency links between the courses and the competency, and the purple one are the semantic links that were missing in the real graph, and it should be enriched by LLM to find these links based on the course data. What semantic connections we identified as important is semantic connection that is called teach same core concept, because on different faculties there are courses that teach the same, right? You will have a statistics on the Faculty of Business, but you also have a statistics on Faculty of Science, and also have a statistics in Faculty of Informatics. So this will link these courses together, and it's important further when we will be selecting the courses to the study plan. Utilize this tool from there are many courses that learn you to use something. Let's call Python for data science, but there is no link to another subject where you can really use it in practice and get the deeper knowledge of it. So this is a semantic connection for that case. It will let you practice it, and then is a deeper dive of that's more. It's the same, but for the theoretical concepts. You can have some overview course that will give you 4 different topics, and then for each topic you have a deeper dive for that. And applies theory from, that's just connection between the theoretical courses to the practical ones that can give you domain-specific use cases. And then there's the multi-centroid graph traversal. What's the centroid? That's a primary competency pillar. That's the real course you start building from. So if we have the enterprise Java programmer, it should be the entry course for programming. And other can be the databases that are not really connected, but are in the competency profile for that job. And there can be a list of these centroids. And then we create a priority queue from it and goes from the most important centroid to the least and start building the curriculum. We have the traversal is constraint aware, and that means some prerequisites, the hard prerequisites set by the university has to stay, right? To have some order in the courses. So if any centroid that's identified has some hard prerequisites that needs to be fulfilled, we go through the prerequisite chain and pick all these courses so he can take this centroid course, right? This mostly should build the vertical bar of the deep knowledge. And then we have the exploratory phase where we are building the horizontal shape of the T, and that means for the enterprise enterprise software engineer, you also need to have some knowledge about project management, how it works, how it works in agile environment, because most of the companies develop in agile settings, right? So course for agile, you will probably present something in corporate, so you should have course for presentation skills, etc., etc. So it builds the different scale of the skills that can be useful in the final job profile. To be auditable, everything could be tracked back, why each decision was made. There's a chain of thought being recorded step by step, or should be step by step recorded. Why this course was picked, what was the courses in consideration instead of this course, and it builds the whole history of how the curriculum was built. And future challenges for us currently, or mostly for me from the technical side, is the data set, because the course data, if we don't strip it to the last 2 semesters, it's really tens of thousands of records overlapping with each other. I would call it mess. There's a mess in the data, and we thought with colleagues the biggest benefit to make this really work will be create an artificial data set based on the real data from our university, but artificially polished to the best version we can use. Also, there are some legal requirements as how many credits you need to fulfill to get a degree. So also one thing is to build the best curriculum based on the T-shape profile of the student, but also he has to fulfill some mandatory things like having enough credits. So this needs to be incorporated into that. And also thinking of the whole mechanism about the weights between the courses and competencies. that will be really challenging. And also the data pipeline, but it's similar to the data set. It will be part of it. Yeah, so if you have any questions, feel free to ask.
Great. Thank you, Patrick.
Thank you.
Questions for Patrick?
Patrick, it's Luke Freund. Would you have any examples of how the courses were characterized relative to the requirements that you were finding for positions? Any examples of how a course was actually viewed for the T-shaped model?
Currently not. Currently, I don't have the mapping between the positions and the competencies and the courses. I work with Clara on that. She was presenting the last occurrence, and yeah, we're still working on it. It's just we are in the phase of the concept, so we have some conceptual things that we want to achieve, but not the real example right now.
Okay. Thank you.
Yeah, I wonder how good the current AI systems are, Patrick, in performing that mapping. You know, you give it a course description and ask the AI to generate the you know, different factors that go into the T model. That might be interesting to see whether it's any good or not.
I mean, just building on what Jim said, I mean, it's a language model. So the language that you use to describe the problem determines how well the AI is going to actually perform. And from the earlier chaps, your comments, taking a transcript, for argument's sake, or a set of transcripts from a bunch of lecturers in a particular topic, and then maybe doing a language model based on that, I wonder what the relationships would be and how what they would look in comparison with the approach that you have taken.
Yeah.
But this goes from a course description, not even at the level of a syllabus. Is that correct?
Yeah, it takes all different sources to build the real course information. It should not just take the syllabi data or syllabi description. That's a few hundred characters, but it also should build on the transcripts and the presentations.
Yeah. And Patrick, how do you see this? As Juha said, flying the T-shaped flag high. How are we going to get broad adoption of all of this? Or is it still too early for a good answer to that?
Not sure if I'm the right person to ask, but academia is one way, but then there will be a long run, right? To make some systematic change how things are being taught. So maybe the way is the companies have the need for the T-shaped professionals, and they will start producing them by themselves, offering them learnings, helping them to spread the knowledge, get the knowledge from different fields they need them to know to be efficient in their work. So yeah.
Yeah, I saw that at IBM, Patrick. In fact, it's you know, the entry-level people were hired for the T-STEM, but in order to move up into the executive ranks, they had to prove they had the T-top.
Mm-hmm. Yeah, exactly.
Yeah. Yeah.
Patrik, can I ask one more question?
Sure.
Thanks for the presentations to start with. Great work you have done. How widely is this T-shaped capability issue kind of embraced in your organization? Is it only you and your research team who is talking about it, or is your university management and other faculties on board, or what's the situation at the moment?
That's a good question. Leonard, do you want to take this one? because Leonard is a leader of our laboratory, and he's involved more in the faculty. I would say it's mostly us, few people at the university, but I think we have some fans there in leadership of the at least at the leadership of the faculty.
Because that's what I feel that is needed, that we need to like-minded people across, as you say, across faculties who share some kind of a mental model, and then things can start spreading and we can start collaborating and so on.
Exactly. And this change will happen much faster in a business than in academia, unfortunately.
Yeah. Might be.
And Lou, do you want to comment on this? That's right up your alley, isn't it?
Well, I think the hesitancy to expect faculties to take this on en masse and start promoting it is a very well thought out position. It's going to be very difficult for us to move this into a university setting. I know that at Western Michigan, they were trying to orient curriculum toward T-Shape several years ago, and had a mindset that graduates would have T-shaped profiles on graduation, but that even has withered away as far as I know. I had some interaction with other faculties, but it's going to be difficult. I think what Mighty Me promotes is the idea that there can be a visual representation of the T-shape and a scoring of the T-shape. And with that, I'm hoping that we'll get more people engaged with the idea of career development along the T platform. But I think as long as we're describing it and waving our hands and trying to explain to people why it's good and so forth, it's just not going to get a following on the academic side. So that's why I've been sort of building out on the Mighty Me model as a way to get engagement with people going forward. We're getting
there. Yeah, just Leonard is writing to the chat that in academia we still have a long journey in T-shape understanding. So yeah, that's pretty much sums it up for our faculty at least.
Well, and thank you all for the efforts that you're putting in to get the T model shared. And that's why ISSIP is running this series in conjunction with Lou, who has the Mighty Me platform. September 9th, we've got Francesco Caputo from Italy, Building T-Shape Professionals for Mastering Digital Transformation. That's a good topic. Then Charles Fidel from the curriculum design world. Charles has industry expertise. He's also associated with Harvard. He's got some books out, so he's going to be talking about curriculum in the AI era with breadth and depth. November 11th, I'll be talking about the T6 model. And December 9th, we're going to have a special roundtable. Hopefully all of us can join, and we'll just have a big discussion of everything so far and maybe look into the future of some of the presentations. And I will get the recording up. Here are the past recordings. And if you can send me, Patrik, your presentation, and you will get this posted. And if any of you can think of someone who might be interested in presenting in the series, by all means, let Lou and I know. And if you read interesting papers and you think that those would be relevant, go ahead and send those to Lou and myself as well, and we'll keep the series going and hopefully find better and better ways to collaborate. And as Juha said, fly the flag high for the T-shaped model. So thank you all. And with that, if there's any other comments, Lou, before we wrap it?
Not at this time. I would mention that we're going to be introducing Mighty Me to a class of UX UI students, the master's students. 38 students will be loading their T-shapes in September into Mighty Me, and we're going to get an evaluation and perhaps some directions for further development. So it is coming into San Jose State at least at one class.
Hey, and we'll get an update on some of the future speaker series, I'm sure. So thanks, Lou. Thanks for that update. All right. Thank you, Patrik, very much. Thank you, Juha. Great work. I agree. Fantastic work and great directions for the future. So thank you both. And
Thank you.
It was our pleasure. Thank you.
Thank you.
All right. Bye for now.
Cheers.
Bye-bye.